Okay, so I've been following the thread on overunity.com where Professor Stephen Jones has a Joule thief, kind of a little bit of a Joule ringer looking circuit running very, very efficiently. He's drawing just microamps and lighting LEDs, and I decided I wanted to take a try at replicating that. So I went back to my Joule ringer bifilar wound coil here, and I put that in place of the resistor capacitor combination he had on his schematic. What else did I do? I wound my primary winding with iron, enamel covered iron and enamel covered copper wire. I started, instead of just doing 15 turns, I started here and I did one layer and then I went around into 2 layers. So there's a lot of turns on my primary. I then came on here with the secondary, and the secondary winding just has a ton of turns. It was 4.5 sewing machine bobbins worth of wire in there, and I just wound that around. I took the start wire here, the beginning of the secondary winding, and I left it free, and I took the ending of those windings and I ran it over here into the positive lead of the circuit. And when I did that, an interesting, before doing that, it just pulled a steady amount of current. But when I did that, the blinking got brighter, and the current draw swings up and down now, which is really interesting. You can see it was at 1.8 here, now it's swinging down. It's going to swing down. Right now it's drawing 0.1 microamp, 0.0 microamps. Now it's swinging back up. I have my multimeter measuring the current between the 1.5 volt battery and this capacitor over here. So I do have capacitors between the 2 points where I'm drawing this current reading, but it's just really interesting to see it swing from just below 2 microamps all the way down to 1 and even 0. And the light just stays the same. You can see there it is at 1 microamp and the light's just blinking along. So that swinging up and down with the current was a really interesting effect, and I'm still exploring that. And I'm also fascinated by the fact that when I connect the ending on my secondary, just the one wire, to this positive lead over here, that the LED gets brighter. I'm going to explore that a lot. And hopefully I can bring this current draw, when it comes down to 0 and hovers around there, hopefully I can help it hover more on that side than the top side, but we'll see. So then I went back to my air batteries, because I was really excited about the potential of driving this off one of my air batteries that you see in my previous videos. So I made this new one yesterday, and what this is it's a carbon core magnesium ribbon. It's got cotton cloth between the carbon core and the magnesium ribbon, and I dipped it in oil. I decided to use oil as, I guess if you want to call it an electrolyte, maybe it's better to put it in the category of insulating it. I kind of wanted to make something like a capacitor with a standing voltage, and I did achieve that. Okay, so what I've done is I've connected the I can't call this an air battery, and that was probably an inappropriate name originally anyway, but I've connected this cell up. This is the oil covered cloth version. So it's basically, like I said, the magnesium ribbon, layer of cotton cloth. The magnesium ribbon wraps around. For those who have not followed my previous videos, it wraps around the carbon rod on top of the cotton as an insulator. I then soaked it in oil. I then put on another layer of cotton. I soaked it in oil again, and I wrapped it tightly with this electrical tape. And you can see that it's driving this little circuit just fine. And what's interesting about that is, with oil acting as an insulator, and it ought to act as a preserver to the magnesium. Could be wrong on that. Maybe oil will not preserve it, but everything I know and everything that I've learned practically would lead me to believe that by soaking this in oil instead of water or letting the humidity from the air run this, that it ought to have great long life and really preserve the magnesium ribbon. Okay, so I want to just bring this up to a little higher power draw so you guys can see how brightly you can drive this LED with very little current. So they're way at 7 microamps. There's 193 microamps. There's sweet spots. So there's about an amp, and I mean a milliamp, I'm sorry. And I just wanted to, I like to experiment with this pulling about a milliamp, because no matter how bad an earth battery you make, you ought to be able to get a milliamp out of it. And it's, well, it's on the milliamp setting, so it actually is running on microamps right now. But you can see the effect. I'm going to go ahead and bring it up so we can analyze this a little better. So it's drawing 0.01 milliamps there. I'm going to go ahead and bring it up to a milliamp. Alright, so there we go. There we go. Now you can actually see the effect that this secondary winding, you know, one end's left open. I'm taking the exiting wire of my secondary winding, and watch what happens when I put it back into my positive line on the circuit. It gets brighter. It's easier to see. Let me switch hands here with the camera. Alright, so here it is without it, and you can see the wave without it, and here it is with it. So it does change it significantly. So right now we're drawing 0.02 milliamps. Yeah, connect this back up. Yeah, 0.02, 0.03 milliamps. Okay, just showing one last thing here. I'm drawing about a milliamp, and you can see the scope shot here. I'm going to take this magnet. It's kind of almost like a horseshoe magnet with it. This is a north and south and a ferrite backing here on it. I just want you to see what I can do to the wave in the scope as I drop this magnet down onto this toroid. You can see that I can control it with a lot of accuracy. Now it's kind of hard to, there we go, to bring it down slowly, but you can see I can tighten that up, and it's starting to ring. I can hear an audible ring. So anyway, you can do a lot of tuning, a lot of adjusting. So anyway, that pretty much covers it, folks. That's the update I wanted to share.